4 says that you are able to draw a Bohr model for the first 20 elements. So what I did was I went online and I found a good image for you guys, and we'll take a look at this here. And this is just omitting those transition metals here, that's why there's a blank space. And we start here with hydrogen, and pull up the drawing tool here, and this is group 1, and this is group 2, 3, 4, 5, 6, 7, and 8. And over here we have periods 1, 2, 3, and the last one, which is the only one that we really are concerned with, is the fourth one, period 4. Alright, so if we take a look at this, we have hydrogen here, and notice that it has one dot. That's indicating that it has one valence electron. If you look at this entire group all the way down, they all have one valence electron, and everything in group 2 has 2 valence electrons. Everything in group 3 has 3 valence electrons, 4 valence electrons. Okay, so these are called Lewis dot diagrams, and now the target's asking you, can you do a Bohr model for each of the following? Well, this is very simple. So the first energy level can hold 2 electrons. So let's just start with helium. So a helium Bohr model would start off with the symbol He, and then we draw a circle around it. Okay, that represents the first energy level. And then we would draw a dot, and then another dot, to represent the electrons. This is the Bohr model for helium. You can always check to see if you're right by looking and saying, hey, helium has 2 valence electrons, and the first energy level can only hold 2. All noble gases should have a full outer energy level, and the first energy level can only hold 2 electrons. This is the Bohr model for helium. Let's try the Bohr model for lithium. If we were going to do a Bohr model for lithium, we could simply draw a circle around the Li, place a dot here and a dot here, and then draw one more energy level because lithium is in the second period, and that leaves us with only 1 electron left over. Now, the atomic number of lithium is 3. Okay, so we would expect lithium to have 3 electrons, 2 in the first energy level until it's full, and then 1 in the next energy level. Lithium has 1 valence electron, just like this Bohr model shows. Let's try carbon. Carbon has an atomic number of 6. Okay, so we know it has 6 electrons. So if I were going to do a Bohr model of carbon, I would simply draw the symbol C, draw a circle around the C, fill up the energy level. The first energy level can only hold 2, and then in the second energy level we'll fill it with what's left over. And in this case, since 6 minus 2 is 4, we know that there are 4 electrons left over. So we place those 4 electrons on the outermost energy level. This is showing us that carbon has 4 valence electrons, just like this electron dot diagram or Lewis dot diagram is showing us. Let's do one more for good measure. Let's look at fluorine. Fluorine has an atomic number of 9. Okay, so we know it has 9 electrons. We're going to draw the symbol F, and we're going to draw a circle around it, and we'll fill up the first energy level with 2 electrons, and we'll draw a second, and the second energy level can hold 7. 1, 2, 3, 4, 5, 6, and 7. And there is a Bohr model for fluorine. If you can do helium, lithium, carbon, and fluorine, then you can do sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. And I'm only going to require that you go from the first element, hydrogen, to the 20th element, calcium.